This video is going to cover the topics from section 6.5, talking about quadratic equations, but to begin with, we need to talk about multiplying binomials, quadratic expressions, factoring quadratics, and then we can talk about quadratic equations as well as look at a few applications. So, to get started, the first thing we're going to talk about is multiplying binomials. Let me see if I can make this. So we're going to be multiplying binomials. So a binomial is simply two. Let me see if I can pull this up. Hold on. A binomial is two terms, such as, say, 2x plus 5. This is a binomial. It has two terms. These cannot be combined. They are unlike terms. Bi meaning two. And when you multiply binomials, for example, you may be asked to multiply these two binomials, you use the distributive property. Oftentimes, this is taught as FOIL, F-O-I-L, but I tend to prefer to think of it as just simply distributing, and I'll talk about that in just a second. So when you multiply binomials, like I said, you're going to distribute. So we're going to take this first term, in this case the 2x, and we're going to multiply it to each term here. So when you multiply on x times x, if you multiply 4 times 4, if you think about it, you simply get 4 squared, or 16. So if you multiply x times x, we get x squared. When we add an x and an x, we get 2 x's. But when we multiply, we get x squared. So when I multiply 2x and x, I'm going to get 2x squared. And then I'm going to multiply this. This is going to give me minus 14x. So we distributed that 2x to each term. And the next is we take the next term here in my first binomial, 5, and we distribute that. So that's going to give me plus 5x. And this is going to be minus 35. Now you can combine your like terms. X squared and x are not like terms because the exponent is different. For these to be like terms, their exponent must be the same. So these two terms are like terms, so that's going to give me a minus 9x minus 35. And here you're finished. We have multiplied these binomials, and as we've talked about in class, we've talked about the word simplify, solve, and evaluate. Here we're just simplifying. We multiplied, we found their product, so we simplified. We cannot solve because it's not an equation, and we cannot evaluate because we don't actually know the value of x. Okay, so let's use these for practice. So here in this first one, this is two binomials, and just real quick to reflect back on what I was saying about FOIL. So if we FOIL, this is first outside, inside, and this is how your textbook explains it as well. So here when you distribute this x to this term, those are the first two terms, and then you distribute it here, so it's the two outside terms. Then you take the 6 and distribute it, so it's the two inside terms, and then you distribute the two last terms. Now, the reason that I don't particularly like this is because I prefer for you to understand what you're doing and not just memorize a mnemonic like this, but also because I want you to be able to apply this to things other than binomials. So if this was a trinomial, say x squared minus 5x plus 7 times a binomial x plus 3, FOIL wouldn't work because you couldn't do first outside, inside, last, but you could use that concept that you're distributing this to each term, and then you're distributing this to each term, and then you're distributing this term to each term. So back over here at problem number 1, when we multiply x times x, we get x squared. Distribute this term to all terms in the second parentheses, so that's going to give me a plus 2x. Then I'm going to look at the second term, which is 6. 6 times x will give me a positive 6x or plus 6x, and then 6 times 2 is going to be 12. Combine like terms, we're going to get x squared plus 8x plus 12. Alright, I'm going to skip down here to problem number 3 just for the sake of time. I will be posting an answer key with the answers to the ones that I'm skipping, so for example 2 and 4, so that you can look at these and check your work if you want these for extra practice. So for problem 3, here I have 2x plus 3 times x plus 5. I'm going to take every term in this first parentheses and distribute it to each term in the second parentheses. So I'm going to take 2x times x. Again, this is 2. There's an understood 1 right here, as we mentioned in class. 2 times 1 is 2. X times x is x squared. 2x times 5 gives me a 10x. So I've distributed this 2x to each term. Now I need to distribute the 3. So that's going to give me a plus 3x plus 15. Okay, so now I can combine like terms. My 2x squared I cannot combine with anything else. 10x plus 3x is going to give me a 13x plus 15. And when I do that, that is simplified. Okay, so let's talk about what we are getting here when we are actually multiplying. When we multiply, let's see. For this first one, we got x squared plus 8x plus 12. And this is a quadratic expression. A quadratic expression is an expression of the form ax squared plus bx plus c, as long as a is not equal to 0. Because if a was equal to 0, then this would no longer have the squared term. And the squared term is what makes this a quadratic equation. So we call this our degree, or the largest exponent here is a 2, and that's what makes this quadratic. So b could be 0, so this could be ax squared plus 0x, and even the c could be 0. That would leave us with ax squared, with a could be, say, 3. And this is still a quadratic expression because it has the x squared term. Now, we call these also trinomials because they have 3 terms, but in the same sense, if I had 7y plus 5x minus 2, this would also be a trinomial because it has 3 terms. But this is not a quadratic equation because it does not have an exponent of 2. This is an expression and not an equation because it doesn't have an equal sign. So we can simplify it, in which case this is simplified by combining like terms and distributing. We could evaluate if we knew what x was, which we've done previously, but we cannot solve these. So when you factor a quadratic equation, or excuse me, factor a quadratic expression, it's I like to think of this as it's similar to that TV show, that TV game show of Jeopardy, where you're given the answer and you have to come up with the question. That's kind of what you're doing when you're factoring a quadratic expression. So for example, if I had x squared plus 8x plus 12, and you may be asked to factor this, what you're actually doing is you are finding the 2 binomials, or whatever it is that you need, to actually give you x squared plus 8x plus 12. They may not always be 2 binomials, but typically when we're just factoring a basic quadratic expression that's a trinomial, then you will end up with 2 binomials. So when you factor a quadratic expression, you're looking for the 2 binomials that you can multiply together to get x squared plus 8x plus 12. So if we go back here and look at our work in the previous slide, to get x squared plus 8x plus 12, to get that x squared, we multiplied x times x, and that's how we got the x squared, which translated, or which moved down here to our final answer. The 8x came from the fact that we multiplied this first term, this first term times that 2, that's where we got our 2x, and then 6 times x, so that's where we got our 6x. So 2x plus 6x, those are the 2 numbers here, 6 and 2. When we add those, that's where we get our 8x. When we multiply those, that's where we get our 12. Now this one's a little bit different here. This is very straightforward because we only have our leading coefficient is only a 1. So this makes this type of problem pretty straightforward. So moving back to where we were here, if you were asked to factor this, because your leading coefficient is 1, you know the only thing that we can do multiply together to get x squared is x and x. X times x is x squared. Now remember this number came because we had two values, something x plus something x, that when we added them together we got 8, and when we multiplied them together they got 12. So we need to look at factors of 12. 1 and 12, 2 and 6, and 3 and 4. When we multiply 1 and 12 we do get 12. When we multiply 2 and 6 we do get 12. When we multiply 3 and 4 we do get 12. When we add these we get 13, so we know those aren't going to work. If we add these we get 8, and that does work. If we add these we get 7, and that does not work. So we know that these two, the second term here has to either be a plus 2 or a plus 6, and the other one's going to have to be a plus 6. And this is our factored form. Now, when we go back here, we've got x. We can check this by distributing. X times x is where I get my x squared. X times 6 is going to give me plus 6x. Then I'm going to take the second term, which is 2, and I'm going to add 2x, and then 2 times 6 will give me 12. Combine your like terms. We get x squared plus 8x plus 12, and this is indeed what we started with. Now this is what we're looking for, but this way we were able to make sure that we got our answer correct. Okay, so let's look at a couple of examples. I'm going to look at problem number 1 here. We have x squared plus 5x plus 6. The key here being that our leading coefficient is 1. If your leading coefficient is 1, then this problem is pretty straightforward. You're looking for two values that when you multiply them you get x squared. Your only options are x and x. Then you're looking for two numbers that when you add them you get 5. When you multiply them you get 6. Now be careful because it's easy to think of 6 and 1 and the difference of those is 5. But if we add a positive 6 and a positive 1 we don't get 5. So what I would do is we were looking for factors of 6 that give us a sum of 5. So the factors of 6 are 1 and 6 and 2 and 3. We want to add 1 and 6 we get 7, so that's not going to work. Add 2 and 3 we do get 5. So because this has a leading coefficient of 1, we can write these binomials as x plus 2 and x plus 3. Both of these being positive, because when we add a positive 2 and a positive 3 we get a positive 5. When we multiply a positive 2 and a positive 3 we get a positive 6. So this is our factored form. To check that we can distribute. X times x is x squared. X times 3 is 3x. 2 times x is 2x. And then 2 times 3 is 6. Combine our like terms, we do get 5x, so we know our answer is correct. Alright, I'm going to skip ahead and look at problem number, problem number 4. I'm going to try 4. Here I have x squared plus 3x minus 10. This is a trinomial, it's a quadratic, so we're going to look and see if we can find two binomials that multiply to give you this. So when we get to get an x squared again, because our leading coefficient is 1, so when you see those leading coefficients of 1, know that your problem is going to be pretty straightforward. So here, sorry my pen's not working, well, I'll just stick here. So to get x squared we multiply x times x. Now here we have negative 10, so now we're looking for factors of negative 10 that give us a sum of positive 3. So when we're looking for two numbers that multiply to give us a negative, we know one of them must be negative and one of them must be positive. When we add them we get a positive 3, so that means our larger value is going to have to be positive. So our factors of negative 10 are going to be a negative 1 and a positive 10, positive 1 and negative 10, negative 2 and positive 5, and 2 and a negative 5. When you combine them, these two give us a sum of 3. So we can put those in here as x minus 2 and x plus 5. paying attention to your signs there. So this is our factored form. Real quick, let's check. So if I distribute, x times x does indeed give me x squared. X times 5 is 5x. Distribute the second term. This is going to be a minus 2x minus 10. And 5x minus 2x is indeed, whoops, wrong problem, 3x. That's just coincidence. 3x. And then 2 times negative 5, excuse me, negative 2 times 5 is indeed a negative 10. So when we multiply these, we do get that answer. So we know that our factors are correct. Alright, so these are a little bit different. In these problems, the leading coefficient is something other than 1, which makes it it's not quite so easy just to pop these into your parentheses. So there's two ways you can do this. Well, there's several ways, but the first way is you can just look at all the different possibilities. So you can just guess and check. So to get 3x, we can multiply 3x times x. To get 28, gosh, we could multiply 2 times 14. To get 3x, this would be x and x. We could multiply 14 and 2. We could multiply 1 and 28. And then, so we need two numbers that give us a positive or a plus 28, but when we add them up, we want them to give us a negative 20. So for two values to multiply to give you a positive number, you know their signs need to be the same. And if they're adding up to give you a minus or a negative 20, you know their signs are both going to be negative. So if we just are guessing and checking, so I just looked at a few of the options. There's obviously more because 28 can be 4 and 7. Let's see, 4 and 7, 7 and 4, 28 and 1. The 28 could be here, and the 1 could be here, and so forth. So if you're guessing and checking, the next point would be just to list your options and then to actually distribute to check. So that'd be 3x. This would be minus, 42. And this would be, when we distribute, that'd be minus 2x. Sorry, that's a 42x. And then plus 28. And you could see, so this is going to give us a negative 44x, so that's not going to work. And then here, you can kind of see what I'm getting at, that guessing and checking is not always going to be the easiest way to solve these, to factor these types of problems. There is a way that you can do this that's a little bit more straightforward. So let me go back in here. And there's nothing wrong with doing this if you want to. If you want to just guess and check, that is just fine. But the other option is there's a process that works each time that you can multiply the leading coefficient, which is 3, times your constant term, which in this case is 28. So let's say 3 times 28 is going to be 84. So this time, instead of looking for factors like in the previous problem, so here we looked for two numbers that when we multiplied them they gave us 6, and we added them they gave us 5. Now that's not quite so easy because we're not just looking for two numbers that multiply to give you 28. We have to look at, take that 3 into consideration. For now we're looking for two numbers that are factors of 3 times 28. So we're going to multiply that leading coefficient times that constant. And when we do that, we're going to get 85. So we're looking, or excuse me, 84. We're looking for two numbers that when you multiply them, you get 84. And when you add them, you get a negative 20. So let's see what we have. 84, and they want to add up to give you a negative 20, so they're both going to need to be negative because they need to multiply to give you a positive. So let's see, 84 divided by 2 is simply 42. A negative 2 and a negative 42 do indeed multiply to give you a positive 84, but they don't add to give you a negative 20, so that's not going to work. Let's see, 84 and 12. So I could do a negative 12 times negative 7, And when I multiply a negative 12 and a negative 7, I do indeed get a positive 84, but when I add these, I get a negative 19, which is obviously closer, but it's not exactly what I am looking for. So the other option is let's see, 84. Let's see, how about negative 14 and negative 6? I believe negative 14 and negative 6 gives you a positive 84 when you multiply them, and when they add, they do indeed give you a negative 20. Okay, so these are the two numbers we're going to work with. They're going to work with negative 14 and negative 6. So the next step we're going to do is we're going to take those numbers and we're actually going to rewrite this problem using those two numbers. Alright, so then from here, I'm going to have to erase this for a second. We've rewritten this problem as with 4 terms, and then we're going to factor this by what we call factor by grouping. Okay, so let's go back here. So what I did was I found the two numbers that multiply to give you a positive 84, and when you add them, give you negative 20. And then I just rewrote this problem. You can see I'm not changing any of the value, because if you were to combine these, you would indeed get back to that negative 20. So now we're going to do something called factor by grouping. And when you factor by grouping, we're going to group these first two values together and these second two, the first two terms. And then we look to see if we can factor anything out of these two. So I have a 3 and an x in this term, and 6 can be divided by 3 and x can be divided by x, so I can factor out a 3x. And when I do that, I'm left with simply an x, and this is a 6x, and when I factor a 3x out, I'm going to be left with a 2. Now in this, I've got a 14 and a 28. Both of those can be divided by 28, but there's not an x term, or excuse me, an x factor in both of those. So I'm just going to factor out a negative 14. When I do that, I'm going to be left with an x in this, an x here, and then a positive 28 divided by that negative 14 is going to be a negative 2. When you, this is called, again, this is called factor by grouping. And when you factor by grouping, hopefully you end up with two terms, so here's a term and here's a term, that have a common binomial factor. So I can factor out my x minus 2, and when I factor this out, I'm left with 3x minus 14. Now, this process may take a few minutes, and hopefully you've seen this before, but you can always check your work to make sure you're correct. But if you stick with this process and you get these values the same way that I did, then you should always end up with the correct factors. And you can see how once you get this process down, then life is a little bit easier than having to guess and check with all the possible options. So let's check this. X times 3x is 3x squared. This is going to give me a minus 14x. That gives me my minus 6x. So you can see those numbers coming back into play here. And then negative 2 times negative 14 is indeed a positive 28. Combine these, and you do get what you started with. So this is your final answer, and we know it's correct. Okay, let's skip here and look at, well, let's look at problem 2, and then I'll leave problem 3 for you to do. Okay, so for problem 2, again, this is a quadratic expression. We know that because it has the largest exponent is a 2. And we're looking for two binomials that multiply to give us 8y squared minus 10y minus 3. Again, you can guess and check by looking at all the possible combinations. This could be an 8y and a y. This could be a 2y and a 4y. And you can see how your options would, this could be a 4y, and this could be a 2y, a minus 3 and a plus 1, or plus 3 and minus 1. So you could guess and check, but it will take some time. So if I come here and use this process that I was telling you about. When you go in here, I'm looking for two numbers this time. I'm looking for two numbers that multiply to give you a negative 24 and add to give you a negative 10. Alright, so negative 24, if this number is negative when I multiply them, then I know one of my factors must be positive and the other must be negative. So I could look at a negative 1 and a positive 24, or a positive 1 and a negative 24, or a negative 2 and a positive 12, or a positive 2 and a negative 12. Let's see, 6, I've got a negative 4, positive 6, positive 4, negative 6. When I combine these, I get 23. That's not going to work. Here I get a negative 23. That's not going to work. When I combine these, I get 10. That's not going to work. When I combine these, though, I get a negative 10. So these are the two numbers I'm looking for. So now I can rewrite this expression as 8y squared minus 12y plus 2y minus 3. When at all possible, it's easier if this sign is positive. Okay, so now I can come back over here. I've got 8y squared minus 12y plus 2y minus 3. Factor by grouping, so I'm going to group my first two terms together and my second two terms together. Factor out a 4 and a y, because 8 and 12 can both be divided by 4, and there's a y in each term. So 8 divided by 4 is 2. Y squared, I can factor out a y, and I'm left with a y. Here, if I factor out a 12, I'm going to be left with a 3, and the y is on the outside. So see, if you distribute 4y and 2y gives you your 8y squared, 4y and 3 gives you your 12y. Okay, if you look here, there's a 2y and a minus 3, and there's nothing we can factor out of both of those, so I will just factor out a 1, and we'll be left with 2y minus 3. Again, you're back down to two terms with a binomial factor that's the same, so we can factor out that binomial factor, and when we do that, we'll be left with 4y plus 1. Alright, be sure to check 2y and 4y is indeed 8y squared. This is going to give me plus 2y minus 12y minus 3. Combine these and I do indeed get my negative 10y, and so I know I have factored these correctly. Alright, in the next video I'm going to talk about solving quadratic equations, but for now you'll want to go back and practice some of these problems and maybe try some of the ones that I've done and stop the video before I actually work them out, and then you can go back and see them worked out in case you have any questions.